So we will be talking about Unit 1, which is amplitude modulation. So first of all, we start with introduction. Being a communication engineer, what is the meaning of communication? Communication is the means of transferring information signals from one point to another point, which are basically electromagnetic signals with the help of electromagnetic devices. The purpose of communication is to transmit and exchange information which contains some intelligence, or the information and the intelligence are the same thing, right? If we go back into the era when there was no languages discovered, no scripts discovered, back then also we used to communicate. Being a social animal, we have to communicate in order to make our daily life going. So we can call it as the purpose of a communication system is to transmit message intelligence of a source to a user. So communication may be defined as a process of establishing connection or link between 2 points for information exchange. So in communication system, there are various parts, out of which one of the most important thing is communication equipments. So the electronic equipments which are used for communication purposes are called as communication equipments. And the complete system, when different communication equipments are assembled together, it forms a communication system. If we go to classification of communication system, there are different bases of different criteria for classification. If I want to classify my communication on the basis of equipments, then I can classify it as simplex, half duplex and duplex. In simplex kind of communication, either transmission will take place or reception. When we talk of half duplex, then the equipment is capable of transmitting and receiving both, but one at a time, like the walkie-talkie. And if I talk about full duplex communication, that is what we do with the help of our today's mobile phones, cellular phones, where we can talk, where we can transmit and receive both simultaneously, right? Now, if on the basis of frequency I want to classify my communication system, then on the basis of frequency I do have baseband and passband communication. What is baseband communication? When we communicate on low frequencies, like man to man, if you have been sitting in front of me and we are talking, that is a baseband communication. You go far and I use a means of communication like mobile phone, then I have to do frequency shifting, modulation. Then that kind of communication is passband or bandpass communication. When I perform modulation, multiplexing, I basically shift my frequencies from actual low frequencies to high frequencies, then that kind of communication is called baseband or bandpass communication, right? Next, one of the very important criteria for classification of communication system is on the basis of type of message signal, that what kind of message signals I am actually transmitting. If I am transmitting analog signal, that is a signal, a sinusoid, right, which would be function of time, right? Then such kind of communication will be analog communication, like most of the signals available in nature, like the blow of wind, the humidity, the change in temperature. If we pass these communication, if we do communicate, we transmit the information in its basic form, then that kind of communication is analog communication. And digital communication, where the message signal is digital in nature, they have fixed levels, right? Like when we communicate using 1-0 binary bits. So these are the basic kind of criteria based on which we can classify our communication system. So we will start with the very basic block diagram of a communication system. We must start, a basic communication system does have 5 important blocks, 5 most critical and essential blocks. The first being information source and input transducer. What is an information source? It will be an equipment or a person that will be generating signals. Like when I am talking, I am generating, my vocal cords are generating the audio frequencies, right? So if the information source could be generating information which could be audio, picture, video, any kind of text, right? So these are the types of information that could be generated with the help of information source, right? It could be a facsimile machine, that could be an audio generator, right? So first task will be to convert that information into some electrical signal, and for that purpose we do use a transducer. So this could be shown as additional block or along with the information source, right? So the next and very important block of my communication system is my transmitter. What is a transmitter? Transmitter is basically a link between my information source and channel. It necessarily checks the characteristic of the input information and matches it with the channel, and checks whether the information available by the information source can pass through the channel, or the transmitter has to make some necessary changes. Then what are those necessary changes, and that will occur at transmitter. So it basically matches the characteristics of the information with the channel and checks whether it can be passed or there has to be done something to it. What can be done? Modulation. Multiplexing. Coding. And many such things that could be done at transmitter. So in this subject, we will be talking about modulation in detail. That was the first topic of the slide which I discussed, which I mentioned, that was amplitude modulation. So we'll be talking about modulation further. So coming to the next block, although I'll be talking about each block in detail, right? So channel. Channel is an abstract used for the physical media that will be used to transmit the information received to the receiver, which is geographically, which must be geographically at a distant place, right? Why have we come to equipments and modulation and such schemes? So that people sitting far from each other, who are geographically separated, they can communicate. So basically channel would be, channel is a term which is abstract for the media which is used for transmitting the signal. So there are many classification for channel. It could be a wired channel, it could be a wireless channel. If I talk about wired channels, we can talk about coaxial cable, twisted pair cable, we can talk about optical fibers. And if we talk about a wireless channel, then we have to see the classification based on the frequencies, like ground wave communication, sky wave communication, space wave communication. We talk of satellite communication, right? So all such communication can be discussed for different kinds of channels. Next is the receiver. Receiver is the device that will undo all the things that has occurred at transmitter. If the transmitter has performed modulation, it will be performing demodulation. If the transmitter has performed multiplexing, it would be performing demultiplexing, coding, decoding, right? If some noise has been added in the channel, which is a universal thing, noise will get added up in the channel, right? Whether it is a wired media or wireless media. Then denoising also has to be occur at receiver, right? Filtering, all the error control techniques, all that we apply at receiver, right? Finally, it goes to output transducer, or we send it to the destination. We can replace this block with destination or the end receiver or end user, right? Right? So end user will be the another person which will be receiving the signal and interpreting the actual meaning of the signal. Right? So all those blocks are explained in detail here. Like information source could be generating an audio signal, image, text, or data, right? An input transducer is a device that converts source to electrical signal, true. The examples for which are microphone, camera, keyboard, right? Next is output transducer. If we talk about it in detail, it converts electrical signal into usable form. That could be speaker or monitor. We are talking about the receiver end. At receiver end, this transducer will again be converting my electrical signal back into its original form, right? That could be a monitor to view, that could be a speaker to hear. What is a transmitter? It converts electrical signal into form suitable for channel. So first task it does is matches the characteristic, and if some alterations are required, it will do that, right? So it basically consists of modulator and amplifier. Modulator is one of the prime equipment of a transducer, which is necessary, right? We will be talking about it in detail. Next is channel. If we talk about channel, we have discussed it is a medium used to transfer signal from transmitter to receiver. It could be either point to point, that is one point to another point, or one point to all points, that is called as broadcast, right? So we have wire lines, fiber optic cables. These are examples for my channel. Atmosphere also serves as a channel in case of wireless communication. Often noise gets added up. Yes, if we are studying communication system, we cannot avoid noise. We have to study noise separately. So I would say the prerequisite for such subject is we should be knowing about signals in system, we should be knowing about probability, and we have to study noise separately, right? So channels are elaborated here: twisted pair, cable, waveguide, fiber optics, wireless. If we talk about transmission of electromagnetic waves from antenna to antenna, which is true, right? That could be kilohertz to, those signals could be ranging from kilohertz to ultraviolet. Propagation characteristics vary with frequency, true. So if I want to classify my wireless communication, we have ground wave and sky wave. Ground wave is low frequency up to 10, it is in kilohertz, and its range is also less. It travels along the curvature of Earth. If I talk about sky wave, it is the communication that occurs in megahertz, up to 30 megahertz. Sky wave propagation, one of the common example is, we used to have our earlier days TV, which used to operate using Yagi-Uda antenna. So signals, they do transfer up to ionosphere, and they are reflected back from ionosphere. Right? Signals reflect from various layers of ionosphere. Changes are based on time, frequency, sunspots. Signal travel around the world. Less predictable propagation. It has a range higher than ground wave. Next is line of sight communication or space wave communication. One of the example is satellite communication, when we transmit in megahertz or gigahertz range, right? Rain is one of the prime factor that affects such kind of communication. Other channels, acoustic channels, right? We can talk about. So now if I want to elaborate the frequencies, we have extremely low frequencies, which varies from 0 to 3 kilohertz, which is used for submarine communication. So here in this slide, I have tried to elaborate various frequency bands and its applications. If we talk about very low frequency, it would be ranging in 3 to 30 kilohertz. Those are used for your submarine communication or time signal navigation. Then comes my low frequencies, that ranges from 30 to 300 kilohertz. right? Applications are written over here. Then we talk about medium frequencies that ranges from 300 kilohertz to 3 megahertz. That is used for maritime voice, data, etc. Right? Then we talk about high frequency that ranges from 3 to 30 megahertz, which is basically used for your broadcasting. Then we talk about very high frequency that ranges from 30 to 300 megahertz, which is used by police or analog TV, or which is used in FM broadcast or in satellite communication as well. If we talk about ultra high frequency, it ranges from 300 to 3000 megahertz. Here we use satellite communication, analog high definition TVs, and rest of the applications are mentioned here. Then super high frequencies, and which ranges from 3 to 30 gigahertz, and then extremely high frequency that ranges from 30 to 300 gigahertz. This is a chart showing the electromagnetic spectrum. Here we can see wavelength from left to right is getting shorter, right? And vice versa for frequency, right? So we can see here that my radio waves fall in this range, my microwaves, if I want to remember, radio waves, microwaves, then infrared, ultraviolet, X-rays, then gamma rays. So it ranges from radio waves to my gamma rays. This chart is important. All communication engineering students must know about it. Then when I talk about receiver, it extracts the estimate of the original transducer output. It undo all the things that has occurred at transmitter, like demodulation, like denoising, decoding, demultiplexing. Amplification is also a part of it. Now, if I talk about what are various losses in a communication system, losses that we face in a communication system are like attenuation. What is attenuation? When signal strength is reduced at receiver because of the long distance communication, long distance traveling it has done. Then distortion, it is the change in the waveform of the signal due to noise, right? It is the change in the waveform of the signal. If the waveform gets distorted, it is not in its original form, then it is called as distortion. If I talk about interference, it refers to addition of unwanted signal. Interference is due to noise, mostly due to noise, is because of the additional signal, additional noise present in the environment, right? Now the next question is, what is noise? Noise is a random and unpredictable electrical signal. What is noise? Noise is again a signal, but that is not desired for us. Like if you and I are talking and somebody else in the back is also talking, so that appears as a noise for me, and that is also a signal but is unwanted for the communication that you and I are doing. So these are random and unpredictable electrical signals from internal or external environment to the system. Baseband and passband communication that we have discussed in the previous slides about classification of communication system. So baseband transmission sends the information signal as it is without modulation. So these are usually low frequency communication. Low frequency communication. If I talk about passband or band pass transmission, it shifts the when we do frequency shifting and then we perform communication, then it is called as band pass or passband communication. Passband or band pass transmission shifts the signal to be transmitted in a frequency to a higher frequency and then transmitted. The process is called as modulation. So modulation is nothing but frequency shifting, where at the receiver the signal is shifted back to the original frequency, right? So demodulation occurs at receiver, so that will be again getting it back to its original frequency. Now if I want to classify my communication system or classify my modulation can be classified as analog modulation and digital modulation. So with the help of this chart, we can start with our amplitude modulation. So we need to understand it first. I can call it as communication classification or modulation classification, right? Both means the same. So modulation can be classified as analog and digital. If I talk about analog kind of modulation, then in a wave, which is a function of time, a simple sinusoid can be expressed as xt, could be expressed as a sine omega t. This is how I represent a wave. A wave does have two things. One, the amplitude, another, the angle, right? If there occurs some alteration in the amplitude, the technique that I use, if I alter the amplitude, that kind of modulation or alteration will be called as amplitude modulation. If I do alteration in the angle of sine, that is my frequency or phase modulation, right? In omega t, we can say omega is my 2 pi ft, right? So here comes the frequency and this is the complete phase angle. So frequency and phase modulation comes under this angle modulation. So such kind of communication is analog modulation. And if I talk about digital modulation, where my message signal is usually represented in binary form, then if this alters, if alteration in the carrier frequency, what is a carrier wave? Carrier is a high frequency wave. We'll be talking about it in detail. When there is alteration in the amplitude of frequency or phase of the carrier wave with respect to my message signal, such kind of modulation is called as digital modulation, and it can be classified as amplitude shift keying ASK, frequency shift keying FSK, or phase shift keying, which is PSK, right? So this is the classification of my communication system. Rest we may talk about what are the advantages of analog communication. Advantages: transmitters and receivers are simple. They use low bandwidth requirement, right? Frequency division multiplexing can be used. Right? If I talk about drawbacks, it is noisy, right? It is not possible to separate. It is difficult to separate noise and signal, right? In case of my analog communication, repeaters cannot be used between transmitters and receivers. Most of the coding techniques available are for digital kind of communication, right? Analog signal requires too much of memory. So if you want to note down what are the various drawbacks of my analog communication, requires a lot of memory, is noisy. In terms of security, coding techniques are difficult to apply. Multiplexing and rest of the techniques that we apply are difficult, right? Applications: radio broadcasting, TV broadcasting, telephones. And digital communication, about digital communication we'll be talking in the next slide. So these are the references that I have used, and that's all for today. Thank you.